Welcome to our IDQ Pro tutorial series. My name is Helena, and today I'll be talking about how to use the Principal Component Analysis toolbox in IDQ Pro. This toolbox transforms the data to a lower dimensional space and finds principal component vectors with their directions along the maximum variance of the input bands. The principal components are in descending order of the amount of total variance. It identifies the principal components from the hyperspectral data and combines the principal components in a pseudo-color image. It plots the spectra of components as well as the cumulative fraction of variance. It then quantifies the area by each component and can save the PCA data into the IDCube format. To start, you'll want to open an image and then navigate to Toolboxes and select Principal Component Analysis. In the component section here, you can scroll through the different principal components assigned to different color channels. The default is component 1 is the red channel, component 2 is the green channel, and component 3 is the blue. Note that only the first 20 principal components can be assessed. So if you scroll all the way to the right, you can only get to 20. You can also assign weights to any of the channels to enhance the signal at a specific channel. For example, you can change this to 2, and you can see that the image has been enhanced. We also have a variety of image enhancements to improve visualization. The current options are contrast saturation limit. The default is 0, and it can range from 0 to 49%. The next one is gamma correction. Gamma correction takes values between 0 and infinity. The default value is 1. If gamma is less than 1, the image is weighted towards brighter pixels. If gamma is greater than 1, the image is weighted towards darker pixels. You can also quantify. If you click the Quantify button, you are prompted to put in a threshold value, the principal component numbers, and the overlay method. Setting the threshold value is optional. The default value is 30 and will be applied to each component. You do not need to assign the values. You can do that in the next step. The next is choosing the principal components of interest, the ones that you would like to quantify. For example, I'll put 2, 3, and 4, and each of them have a space between them. The limit to the number of components you can put in at any given time here is 10. You'll then choose the overlay method. The first one is SAM, spectral angle map, which is the default. The next is SID, spectral information divergence, and the last one is SID-SAM, spectral information divergence, spectral angle mapper hybrid. Once the toolbox has loaded, you will then be given the following information: a pseudo RGB rendering of the original dataset, these threshold values here, and then you'll be given the following histograms. So you might consider looking at the values here: 70, 85, 98.5, 97. So as you can see, all of them are threshold at 30, which is well below the limit here, and no overlay has been presented. So to start, if we want to look at component 1, we might consider putting 80 in and clicking apply. You can now see that the first component is the leaves. But as you can see, it's quantified both leaves. If you want to see if there's any distinction, you can click on the histogram and see that there is 2 peaks here. So you might consider using a value of maybe 71. And click apply threshold. And that delineates the 2 leaves a little bit better. Again, you can look at component 2. Each histogram corresponds to that component, and you might consider looking at something around 85. If you want the particular number, you can click on that tool, and it's 85. You'll change the value at 85. So it's important to note that the green area here is in reference to the second component, and the area is given here in pixels, 9366. You can continue to make these distinctions and see where the overlaps are. You can continue to manipulate all of the histograms and the thresholds in order to get an overlay that you like. For more information and references, visit idcubes.com/documentation.